So, I am doing how to draw an atom, which is basically what these elements on the periodic table look like. Yeah, mine just got kind of ripped. I am only a grade 9 student. And so the first part you need to know about drawing an atom is the electrons and the protons. Those numbers are decided by the atomic number. And the neutrons are decided by the atomic mass minusing the atomic number. And so I'm going to give an example of doing neon. So the neon that is normally here
So what's the writing?
So I did what the normal neon would be on the normal periodic table. So the atomic number of neon is 10. The atomic mass is 20.2. And the symbol for it is Ne.
Okay.
So when you do it this way, where you round the number to the whole number,
Right.
it would be a whole. So the way it would look if it was like a whole number, the whole entire thing, the whole entire picture would still look the same, but it's changed. But the atomic number will not. So the atomic number is still 10. The symbol does not change,
Right.
but the mass does. So the atomic mass, so 1, 2, 3, 4. These you round down. And 5, 6, 7, 8, and 9 you round up.
Okay.
So since neon has an atomic mass of 20.2, that would change to 20. So usually the way you draw an atom is so this circle, which is bland, it's a circle, is the nucleus. And so what you do on the side for, an atom, you would put down certain things, like the number E is number of electrons.
Right.
And then there would be the N for neutrons,
Okay.
N the protons, and the number of shells. Now the shells are the dashed lines. And the way you determine how many shells it has
Mm-hmm.
is the periods on the side, which are the lines going, well, it goes down.
Okay.
So anything in row 1
Mm-hmm.
that way, it only has 1 shell. Second period, 2 shells, 3, 4 would be 4. Now, since neon is only on period 2,
Yep.
you would have 2 shells.
Right.
And the protons and the electrons. So since the atomic number of neon
Mm-hmm.
is 10, both the electrons and the protons,
Mhm.
are both 10. Now, what you would do to get the neutrons is you would 20 minus 10, which would equal 10. So inside the nucleus, you would put 10p
Mm-hmm.
and 10n. Now for neutrons or the protons or electrons, it depends on where you are on the periodic table for this to be a not a neutron, an atom.
Mm-hmm.
So what the shells are, you just put a dashed line all the way around. Now however many, it's bigger.
Oh,
So
I see.
these
There's two
are the shells.
Got it.
Now these are the protons and the neutrons. Now the first shell has the maximum number of 2 electrons. So since you can only have 2 electrons, the first shell, you would just have 2 like this.
Hmm.
So the dots are the electrons. Now the electrons are the negative. So they're the negative. The protons are the protons are positive, and then the neutrons are neutral. So they do nothing because they're neutral.
Hmm.
Think of it as a way of magnets. You put the south side onto the north side. They go together. But if you do south side to south side, they will go away from each other. That's how the electrons work.
Cool.
So, second shell can only have 8 electrons. Now the third,
If there was a third,
yes, if there was a third,
like magnesium.
the max number is also 8 electrons. Now the fourth shell, the max number of electrons is 18.
Wow, 18.
Yep. And so you have, so since you've got only 2 on the first shell, you need to put 8 on the second shell.
Mm-hmm.
2, 3, 4, 5, 6, 7. So there's 8 on that shell.
Okay.
And then there you go. You got the atom.
And that's a neon atom.
Yep. And so all the noble gases
Mm-hmm.
will have an equal atom. So neon is a noble gas. So that means the atom is all perfect. So you've got 2 in the first and 8 in the second. That's the exact amount for the first and second shell.
Right.
And now on the back, I'm going to do potassium and calcium.
Mm.
Now those are the hard ones. Mainly considering that potassium has an atomic number of 19. The atomic mass is 39. So, what I'd usually do is I'd count down tens, and then I would go down by the 9, because 39.
Mm-hmm.
So, that would leave me, so 39 minus 19 equals 'I'm having a brain fart. 39.
20.
So that'd mean 20.
Okay.
So that is the neutron. 19. That is for the protons and the electrons.
Right.
So now, since it's got 4 shells,
Right.
this one's going to be a bigger one. So you got your 19 protons
Mm-hmm.
and your 20 neutrons. So once you get
But they're
that,
not even.
yes, they're not even. But that's the way an atom works. They're uneven and they're even.
Mm.
The noble gases are always even, and the non-noble gases are all uneven.
Interesting.
So you have the nucleus, you have the protons and the neutrons in, and then you draw your dashed line around it. Since I'm doing potassium, I am going to do 4 shells. So potassium. 2 in the first, 8 in the second, So that's 10. 8 and a third. That'll leave 18. So since there's only 9 electrons, you'd only need to add 1 more.
Why?
Because then there will be 19. Because with this,
Oh, gotcha.
the first and second shell
Mm-hmm.
will equal up to 10
Right.
once filled. And then the third will equal to 18. And to get 19, you only need to add 1 electron in the fourth shell.
Hmm.
Now on the other side,
Interesting.
I'm going to do calcium. Calcium. So I need to get the mass and the atomic number.
Mhm.
So 40 minus 20 equals 20. And that is the neutrons. Now the protons and electrons are both 20. Now since that, we've got that information. Nucleus. Well, where's the eraser?
No, that's fine.
No, it's too tiny.
Oh, you can just put 20 in, 20 and 20 in there. We'll understand.
So you got that.
Yep. And this is 4 shells as well, because it's on the 4th row of the periodic table, right?
Mm-hmm.
Okay.
That's the second shell. That's the third shell. And there's a fourth shell. Now to get to 20, we're doing the same thing.
Mm-hmm.
2 in the first, 8 in the second, 8 in the third. But now, it's 2 in the last.
Right.
So we're at 10. We're almost at 18.
So it's 2, 8, 10, and then 10. Maximum of 10 in each of the rows after, right? 2, then 8, and then it's maximum 10.
Nope, 2, 8, 8.
Oh,
18.
8, 8, 10.
First shell, 2.
Mm-hmm.
Second shell, 8. Third shell, 8. Fourth shell, 18.
Oh. Okay.
And that's potassium.
That is really cool.
I thought you were doing calcium.
Calcium.
Well, calcium. Yeah, I just said it very far. Again.
That's okay.
Hey, awesome job.
And so, this is the work I've done. This was the first starting. We did hydrogen.
Mm-hmm.
Then we did helium.
Right.
That was period 1. Now for period 2, we did all of these.
Whoa.
We did lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, and neon.
Wow.
So is that your exam?
This is not my exam.
Okay.
This was just like preparing me.
Oh, okay.
Very good.
Rutherford diagrams.
Okay.
I thought it was Rutherford.
Yeah, it's Bohr Rutherford. Cool.
And then there
What's
was
this one?
period 3. So we did sodium, magnesium,
You got a
alum,
happy face there. The teacher gave you a happy face.
aluminium, silicone, phosphorus, sulfur, chlorine, and argon.
Mm-hmm.
Now, I did perfect on all of that. And for my last one was period 4. Now, I did potassium and calcium.
Mm-hmm.
And I got perfect for both.
Awesome. Good job.
Very impressed, James.
So thank you for teaching Dad about what you do in science.
Yeah,
Yep.
this is awesome. Thank you.
And I think
One last look.
Winston got bored and went to bed.
And one last look at
Okay.
what you need
Oh,
to
we
know.
did- Yeah. I got a shadow.
And potassium and calcium.
Good
Somebody
job.
heard you say his name.
Winston's saying, "Are you done yet?"
And here's our
Winston.
little puppy. He's so beautiful. He can be a little nosy sometimes.
Mm-hmm.
And a little pulley. And naggy sometimes.
Okay. Over and out.